So for the next part, for part 2 of this, we're going to break this into 2 parts as well. We're going to talk just about the multiplying portion of this. Our rule when multiplying, when we multiply with the same base, we keep the base and add the exponents. Our multiplying rule says that a to the x times a to the y equals a to the x plus y. We're multiplying with the same base, we keep the base, we add the exponents. So for example, on number 5, when I'm multiplying and the base is the same, I keep that base and I add those exponents, 2 plus 6. The common mistake that I saw there, for those who missed it, was they wanted to make that 49. We're not multiplying a times a. The base doesn't get multiplied. The base, this is saying I have 7 times 7, and I'm multiplying that by 7 times itself 6 times. How many 7s do I have? 1, 2, 3, 4, 5, 6, 7, 8. So 7 squared times 7 to the 6th is equal to 7 times itself 8 times. Keep the base, add the exponent. Now we don't want to have to write the expanded form every time, so we go to the shortcut of multiplying with the same base, keep the base, and add the exponents. For number 6, we're doing the same problem. C to the 9th, d to the negative 2nd times c d to the 9th. We're just looking at the like parts. So I'm multiplying c to the 9th times c to the 1st, and that gives me c to the 10th power. And I'm looking at d to the negative 2nd times d to the 9th, multiplying with the same base, keep the base, and when I add negative 2 plus 9, I get positive 7. So we did the same thing here, even though we had different factors here, we're still multiplying with that same base, keeping the base, adding the exponent to get our answer. As I look at number 7, 6w to the 3rd times negative 3w to the 4th. We're going to multiply our 6 times negative 3. Notice our coefficients still get multiplied. 6 times negative 3, negative 18. It's still a multiplication problem even though we have a shortcut for the exponents. Now I do my w to the 3rd times w to the 4th, multiplying with the same base, keep the base, and add the exponents. As I look at the next one, I have 8 times 4, 32. A to the negative 2nd times a to the negative 9th. What's our rule? Keep the base and add the exponent. But we learned, one of the first things we learned about exponents is we never leave our answer with a negative exponent. It's okay to have a negative coefficient. That's fine, but we never leave a negative exponent. So what do we do with a negative exponent? We go to the denominator and change the sign. Cross the line, change the sign, or take the reciprocal of the base to the positive exponent. A few ways we can describe it. Notice the 32 doesn't move with it. If there were parentheses around it, the 32 would have traveled with it. But because there's no parentheses, that negative 11 is only the exponent to the a, not the entire 32a. So those parentheses around the base, and recognizing that is very, very important. Make sure you understand how we did that. Number 9, last one we'll do in this section, same thing. Negative 5 times negative 4, positive 20. R to the negative 1st times r to the 9th, keep the base, add the exponents. S times s to the negative 6, remember that s, if you don't see an exponent, it's automatically 1, would give me s to the negative 5th. Notice how we're just looking at it a piece at a time. We're not looking at the entirety of it and the complexity of it. We're just saying, what's my coefficient going to be? What's my r piece going to be? R to the 8th. What's my s piece going to be? S to the negative 5th. And then we clean it up. Anything with a positive base is where our exponent is where it's supposed to be. So my 20 has a positive 1, it stays on top. My r to the 8th has a positive 8, it stays on top. But my s to the negative 5th has a negative base. It has to cross the line and change the sign, or go to the base and change the sign, or take the reciprocal of the base. A lot of ways we can describe it, but all of them correct that negative exponent. With the exception of scientific notation, we never leave a final answer with a negative exponent. We're going to do one more video. It's going to talk about the division property. Make sure you input these, and you have to make sure you input these final answers, not the first one, just that right there. Make sure you're inputting these answers in Edge Elastic to give you the opportunity to show you've watched the video, answered the questions, and hopefully improve your scores. Have a great day.